Hello my dear students, welcome back to the next edition of integration by substitution. By substitution, yes, we will now start with exercise 7.2. Here in this video I will try to solve around about 10 random questions. I will be doing this in two videos, two parts, so that it doesn't become too boring for all of you that you have to wait for more than 1 hour in the video. So we'll try to make it as short, as brief as possible with any of the 10 random questions that we will solve. Please watch the full video, because with every formula questions there are some questions which I will be giving you some special formulas. If you remember our substitution, coefficient, in the last video I talked with you about those shortcuts and small tricks on that. So I'll be giving you more formulas based on that. So please, yes, watch the full video. Bring out your pen and paper. What are you doing? Bring out your pen and paper and let's begin with the exercise. The first part of exercise 7.2. Let's start with, let's say, question number 2. Chalo. Question number 2. The question says, integrate the given functions with respect to, of course, x. That's understandable. So our function is log x whole square, log x whole square upon x. So we will integrate this given function with respect to x. Important, I equal to integral of the given function with respect to x. Okay, now as we discussed, substitution, another one method to help us with integration. So what we can do here is, as I told again, many things I used to say, isn't it? How many do you remember? What did I say? Differentiation is a very important part for integration. If you want to do well in integration, differentiation is going to be very important for you. Because based on that only we will be able to integrate, no? Substitute actually. So here I can identify, can you? Yes. So what we can do is let log x be t, because if we differentiate, of course this sentence I will not be writing anymore, just for this first problem, so that it will be a revision of that previous problem. So derivative of log x is 1 by x dt upon x. So 1 by x dx equal to dt. So I have to replace this, isn't it? So now then I can go for the substitution. That is, then in that case my I will be, this is t square. Now 1 by x, 1 by x of dx. 1 by x of dx is what? Simply dt. So come ho gaya. So that's quite simple. That's 2 plus 1, 3 divided by 3 plus c. So I think you can catch up with me here, because we don't want to be wasting too much of time explaining the simple problems. Now, let's try number 3. Question number 3. You can always pause the video and note down. Okay, always pause the video and you can note down. Question number 3. Okay, what do we have with the question 3 there? I is equal to 1 upon x plus x log x. Of course, with respect to x, that is important. Now here, I can't really make out what should I substitute here. So, maybe something like this. I see log, so almost only plays with log. So, since I can't make out, maybe I will just settle things down properly. That is by taking x common. So, that's going to be log x. I think this might help, because 1 plus log x, if I substitute, then derivative, now I'm doing directly, differentiating both sides now. So derivative of 1 is 0, derivative of log x is x. With respect to x, I'm bringing it up there. So now if you see there, I think this is okay, isn't it? Deriving with respect to x, 2-3 steps I'm reducing. So you can see that 1 by x with respect to x, 1 by x with respect to x is dt. This is substituted as t. So that's why you see that's why I'm saying this differentiation actually is a very key role, plays a very key role. So this will be 1 by 1 plus log x is t, then 1 by x into dx, that's simply dt. So that is simply what? Log of t plus c, so that is log of 1 plus log, no need the bracket, 1 plus log x plus plus c. Got it? I think that's fine. Okay, we can move on to 5. Okay, 5, question number 5. So here I'll be giving you one particular formula, direct application. Many ways we can do this. The one which I'm going to give you, this formula you can always use. Remember regarding the substitution, coefficient substitution and all, especially if you don't want to do too long integrations. Number 5, that is integral of sine ax plus b cos ax plus b with respect to x. I just wrote without looking at the question. After that, that's fine. Chalo. What I'll do here is I'll be giving you one formula. I hope you're ready to note down that formula. It can be used for the other trigonometric ratios also, but I'm going to rub it very soon. So that's going to be quick, right? Quickly. So that's going to be sine of ax plus b with respect to x. If you remember, I'm not going to tell you because you can go and watch the previous video. I already talked about that substitution part, no? Integration coefficients. So here also that's based on that only. So that's going to be minus cos ax plus b. Divide it simply by the coefficient of x, that is divided by a. Coefficient of x is a. Somewhat similar to chain rule. Somewhat, not exactly chain rule. That's what I was telling you in the previous video also. Substitution, substitute the, if you want to do it directly, sometimes you're in a hurry, we cannot do all the steps of substitution. Fine, no problem. Use the coefficients, just use the normal integration, assuming somewhat similar to chain rule, and then just use the coefficients. No? Yeah. So, written now. I'm rubbing it off. Okay. So you can use these formulas. Similarly, it will be for cos also and for other trigonometric ratios also. Alright? Okay, so now I'll try to use that formula. There are other ways in which we can substitute also, but at least for that sake I've given you a formula, so let's use that particular formula. So 1 by 2 sine of 2 ax plus b with respect to x. So yes, some of you must be thinking, ye kahan se aaya? How did this happen? Trigonometry, you have studied class 11. Yeah, remember, twice of sine theta into cos theta is what? Sine 2 theta. That's what I'm using. Theta, twice of sine theta, cos theta, sine 2 theta. So 1 by 2 integral of sine 2ax plus 2b with respect to x. So now here you can apply the formula that I gave you just now, that is minus of cos of 2ax plus 2b divided by the coefficient of x, that is 2a plus c. So minus cos of 2ax plus 2b by 4a plus c. Now of course you will want to modify the 2 common. If you want to compare it with the textbook, 2 common, ax plus, doesn't matter, it's all the same. Come on, 4a. 7, shall we? 7, shall let's do 7. Question number 7. Integral of x root over of x plus 2 with respect to x. Root over of x plus 2 with respect to x. Okay, what can we do here? Direct substitution to possibility. I think we can. Not a big problem there. But anyway, let's just do something else. X plus 2. Oh, x plus 2, I can do it as t square, x can be t. No problem with that also. If we just substitute x plus 2 as t, then x plus 2 will be t square. So dx will be dt. In that case, x will be t square minus 2 t cube by 2t. I think this will also work. But I will not prefer this. Root, yeah, that I think that will also be good. Not a big problem, I guess. Let's try. If it's wrong, it's okay, no? Let's not waste time. Let root over of x plus 2 be t. So in that case, x plus 2 becomes t square. If it is wrong, it's okay. We do not get. We will try by another method. So deriving both sides, we have only dx here because it's 1. So dx comes up. Still wondering how. Yeah, this is 1. So this is 2d dt by dx. So dx, so I'm just doing directly now. Dx equal to 2d dt. That's what I'm doing. Yeah, sometimes you understand now. So I becomes integral of x. So what will be x? So in that case, x will be t square minus 2. So that's going to be t square minus 2. What is this value? This I've used as t. What is dx? Dx 2d dt. Twice d dt. Rub off. So then what do we have here? That's going to be twice of t square. T square minus 2 dt. That will be integral of twice of t power 4 minus 2 to the 4 t square dt. So that will be t power 4. I have to write to finite all these steps. I don't want to write, but t power 5 by 5 minus 4 into t cubed by 3 plus c. Now you can put in the respective values. That is 2 by 5. What was the value of t? Root over of x plus 2 whole power 5 minus 4 by 3 root over of x plus 2 whole power 3 plus c. So now root over, I don't have to explain that to you in class 9, not 9, 12. Square root means 1 by 2. 1 by 2 into 5, 5 by 2. So that becomes 2 by 5, x plus 2, 5 by 2 minus 4 by 3, x plus 2, 1 by 2 into 3, 3 by 2 plus c. Okay? So that is done. So next what shall we do? 10. Okay, 8. Integral of x root over of 1 plus 2x square with respect to x. So let's continue. This is quite easier. That is, let 1 plus 2x square be our t. So differentiating both sides, 2 is already there. This is 2x dx. I'm bringing it from down. Just now only I showed you now. Okay, so that's going to be 4x dx is equal to dt. What shall we replace if this is t? So x dx, maybe this we can replace. Otherwise, you can just write dx in the next step. When you substitute, you can cancel also. That also can be done. I want to do it directly, but I don't have time to wait for anyone. So, fine, immediate substitution. So that's going to be I will be equal to, this is root over of t. Dx, x into dx, this value x into dx dt by 4. So that's 1 by 4 integral of t power 1 by 2 dt. So that's 1 by 4, t power 1 by 2 plus 1, how much? 3 by 2. 3 by 2 plus c. So that's 1 by 4 into 2 by 3 into, what was the value of t? 1 plus 2x squared, 3 by 2. 3 by 2 plus c. 2 2s are 4. 2 3s are 6. 2x squared, 3 by 2 plus c. That's fine, I guess. No problem there so far. 1 by 6, 1 plus 2x squared, 3 by 2 plus c. I have to compare with the textbook answer also because it has to be matching. Even though it's correct, if it's not matching, then some of you will think that, yeah, sir, you did wrong. No? So, I have to keep in view the textbook answer also. Why nahi? Chalo. Okay, 10. Integral of non-stop. Because we are racing against time, because it seems like you get really bored watching videos that are more than 10-15 minutes. So let's try to quick, at least half an hour to concentration banta hai. Yeah. Come on, you're studying. So when you're studying, if you tell me that your concentration is not even half an hour, that's shame on you, yeah. Okay, so what can we do here? X. A little bit of simplification. Without simplification also we can do that. Is let one option is, okay, root x be t. Then x is t squared, and differentiating both sides, dx is twice t del t. That's fine. Okay, so let's substitute. So I equal the integral of 1 by x is t squared minus root over of x is t. Dx is twice t del t. So that's going to be twice of t. By taking t common, I have t minus 1 dt. 2, what am I doing? 1, 2. T cancels, so I have 2 integral of 1 by t upon 1 dt. Integral of 1 by 2 upon 1 dt. So here again I'm going to give you one formula which you already know. That is, as long as the integration, write down or take a note or listen. Integration of 1 by x is dx. With respect to x is log of x plus c. This you can apply in any kind of formulas. X plus 2 also. You can write log of x plus 2 plus c. No problem with that. You can just assume this as x also or t also. As long as the coefficient of x or the variable is a linear term and it is free of any coefficients. And if there are coefficients here, we divide the entire integration by that particular coefficient. That means x plus 2. So you can see the coefficient of x is 1 and it's linear, x power 1. So I can just write log of x plus 2. If it's log of x minus 10, then also same, because coefficient of x is how much? 1. So we will divide by 1 only. No big issue there. So x minus 10. So that same concept if we apply there, then that will be I equal to twice of log t minus 1 plus c, because coefficient of x is 1, t is 1, so not a big problem there. So twice of log t, what was the value of t? Root over of x. Root over of x minus 1 plus c. I think that will be fine. Twice of log root over of x minus 1 plus c. Question number 12, quick. Integration of x cube minus 1 by 3 x power 5. Don't forget to put with respect to x. So here what can we substitute? Question number 12. I also don't know, man. What can we substitute? Maybe a little bit of adjustment, because this is the only thing that I can substitute, because whole power 1 by 3. So as long as this is sorted out, quite difficult to integrate. Not impossible, but kind of messy to integrate. So x cube, that means, let me try something. That is x power 5. I think no big problem there. I don't think that 2 3s are 6. Why am I writing 5? X power m plus n is x power m into x power n, law of indices. So don't think of those stupid things. Okay. Yes. I think that's fine now. I think we can integrate now. Let of x cubed minus 1 be t. Then differentiating both sides, I'll have 3x squared with respect to x is equal to dt. So 3 2 we don't have, no problem. So I will just use x squared dx dt upon 3. I think that will be fine, because x squared dx I can substitute now the whole term. That means this variable dx might not be a big problem for us. So in that case my I will be, what is this value that I have used? T power 1 by 3. No problem. X cube, what can I use? X cube I can use t plus 1. Not a big problem there. T plus 1. This time what can I use? dt by 3. Oh yeah, though. dt by 3. So now if I 1 by 3, if I just multiply t power 1 by 3 plus 1 plus t power 1 by 3 dt. So that's 1 by 3, t power 3 plus 1, t power 4 by 3 plus t power 1 by 3 dt. Now the job is just to integrate after that. X cube plus 1. So our job is just to integrate 1 by 3, t power 4 by 3, that is 4 by 3 plus 1, 7. 7 by 3 upon 7 by 3 plus 1 by 3 plus 1, 3 plus 1, 4. 4 by 3 plus 4 by 3 plus C. Okay, now, so let's simplify. 1 by 3, 3 by 7, t power 7 by 3 plus 3 by 4, t power 4 by 3. Pardon me if I'm making any mistakes, you can please make the necessary corrections. 1 by 7, okay, what was the value of t that we used? The value of t, x cubed minus 1. X cubed minus 1, 7 to the power 3 plus 1 by 4, x cubed minus 1, 4 by 3 plus c. 3, we can cancel. So ultimately, I will not write again. I am kind of very lazy. So ultimately, finish. No, 3 cancel, isn't it? So the next line, I will be equal to. So this is gone. 3 cancel. So I will be equal to 1 by 7 of x cubed minus 1, 7 by 3 plus 1 by 4 x cubed minus 1 whole power 4 by 3 plus c. Got it? Okay. Alright, let's continue again with at least two more questions. 14. I think we can finish up 2 more questions. No, because you told me that you have patience for at least half an hour. So let's try your patience today. That is, x should be greater than 0. Okay, no problem. M is not equal to 1. No problem. M is not equal to 1. Okay. X should be greater than 0 because log x has to be defined. Yes, that's understood. M is not equal to 1. What will happen if log m is equal to 1? There might be some problems if m is equal to 1. What may be the possible problems in that case? Anyway, let's just forget about okay, if m is not equal to 1, if m is equal to 1, what will happen? If m is equal to 1, we will see. Now actually even I also can't say. Maybe there is something related with the answer. So let's see what happens. Of course x is greater than 0. That's understood because log x has to be defined. No problem. So substitution is quite simple. We will see. I'll definitely talk about m not equal to 1. Why? Okay. Log x equal to t. So 1 by x with respect to x is dt. So this is, I think, a simple problem. I will be equal to 1 by t power m. I forgot to write d. So dx, 1 by x dx. 1 by x dx is dt. So that will be t power minus m dt. So that's t power minus m plus 1 minus m plus 1 plus c. Now I hope you're getting a small idea on why m should not be equal to 1. Finished now, I'm rubbing off. You need to be quick. Or of course you can always pause the video, yeah. T power 1 minus m 1 minus m plus c. So what was the value of t? Log x 1 minus m 1 minus m plus c. I believe now you understand why m cannot be 1, because if m is 1, we will have 1 minus 1, that's 0, so that is not going to be defined here also. Of course here it's going to be 1, so ultimately we'll have 1 by 0, which is not going to be defined. So that's why they are very strict on that. M cannot be 1, because if m is 1, then we are getting a solution which is actually what? Not defined. So that's the reason why m cannot be 1. X greater than 0, yes, log x has to be defined, because log x is particularly not defined for negative values, so we don't do that. Do we have time for one more question? I believe we have, if you're interested. So last question, that is number 19 for this part. E power 2x minus 1. E power 2x plus 1 with respect to x. Now before I solve this, what I'll do is I'll divide both of this numerator, each term, okay, I'll do like this, by e power x. I'll divide both numerator and denominator by e power x. So e power 2x by e power x minus 1 by e power x. E power 2x by e power x plus 1 by e power x with respect to x. So in that case, I'll have left with e power x minus e power minus x upon e power x plus e power minus x with respect to x. So that's my I. As of now, I haven't substituted yet. Substitution part 2, it will come now only though. Why? Because I know what I was doing, because differentiation was a good concept with me. So based on that differentiation concept only, because I know that if I can get a relation something like this, if I substitute the denominator, I will be getting the numerator substituted. How? Let's see, I'll show you. So then, that e power x plus e power minus x dt. I hope you haven't forgotten the chain rule differentiation. You can always check the videos which I've made for you. Now differentiating both sides, e power x will be e power x plus e power minus x will be minus x, but the chain rule will continue. I don't want to be talking too much again on the chain rule of differentiation. This is well known to all of you. So e power x plus e power minus x minus 1 dt. Here I'm writing, just to be more arranged, I'm writing dt by x, so that I don't want to be confusing with too many stuffs. So that's going to be e power x minus e power minus x dx is equal to dt. I told you now I'll be getting the numerator, so that's going to be, this is dt, this is t. So that's simply log of t plus c. So that's simply log of e power x plus e power minus x plus c. E power x plus e power x plus e power minus x plus c. This chalk is really giving me a big problem. Okay, so that's it. So that's the first part of the video for exercise 7.2. Next part of the video, which I'll be again doing very soon, that will be on the remaining part of the questions, maybe another 10 random questions. If you have any questions which you want me to solve from the remaining questions, you can please comment maybe today itself or as soon as you get to see this video at the earliest, so that I can solve those specific questions for you also. Okay, so alright, till then, practice well, take care, see you very soon, bye bye.